Hi, I am Mohammad Musab from 6th semester A section and I am going to explain my open-end program for computer networks lab. We need these two files, client.py, server.py. I'll attach these files in the description itself. For now, you have to open this particular folder in the VS Code. VS Code is not mandatory. I will show you another way how to execute this program without VS Code. For now, you can, if you are not getting open with code, you can use open folder. That's okay. I will first show demonstration of how this works. First, open the terminal using command and tilde key, or else you can just use terminal and new terminal. That's okay. Run the command python and our file's name server.py in order to open a server which listens at this host IP address. Next, go through the client.py file, use the same things and just run the particular file python client.py. Here comes our video transmission window. Okay, here's the transmitting video and here's the receiving video. It's actually my camera. The server is sending the video and the receiver receiving the video. You can just press Q to exit. I will show you some other way how to run this thing if you don't have VS Code. Go into your folder, press left shift and press right click on your mouse. Then you can use open PowerShell window here. Do the same thing once again so that we can run the particular command in the server for server as well as client. Keep it aside. Run python server.py here and here python client.py. Same thing. Okay. You can just again press Q in order to exit. Now I will explain the code how this actually works. Open the code. We need this 4 module in order to run our program: socket, CV2, pickle and struct. Pickle and struct have the same purposes, almost same purposes. We are just converting some other formats into our byte format. For example, converting a string or converting a integer or object into our byte format. CV2 is used for capturing the video and as well as displaying the video in client.py, and socket is used for configuring the socket. If you don't have the modules here, you can just install the module using the pip command, pip3 install or pip install the particular module which you want, like example CV2, and hit enter. I have already installed it, so I won't do it again. Okay. These codes are actually used for configuring the socket. Now we are configuring the socket in first way using the socket method attached to this module, socket module. Socket.af inet means we are using this for IPv4, which is by default. We can also use IPv6, for example here af inet IP6 inet 6, and we are using this as a socket stream. It can be stream or datagram, you can configure it, but for now we actually need socket stream. Now using this command we are actually getting the host name. For my computer it is Musaib, so we'll get Musaib here. For example, if I run this program once again, you might have already seen it, python server.py. Here host name Musaib, which is actually the print command of print line from the after this line. Host name. Now host name variables actually stores this name using the socket.get host name. Just kill this. Next, host IP. You are getting the host IP. We are getting the host IP through the host name. We are passing our host name as an argument to this, and we are displaying it later. Now we are using the port 9999. You can use some other port which is actually not being used by some other program or some other software. Now we are making a tuple which consists of host IP as well as host port. Now we are sending this tuple as an argument to the bind of server socket. Now later we start listening at this port which have been provided by us. As soon as the listening starts, we get our print command listening at and the socket address. Okay. Now comes the loop. For the loop, we are using server socket.accept. This will actually run after we start listening to it through the client.py using this command client.socket.connect. When this executes, then the accept method receives the information from the client. The while loop continuously runs after it gets the acceptance of the client. Then later we have got the address as an argument. It's actually similar to object or array destructuring. For example, client socket comma address is equal to any information sent by the client or received by the client. For example, if I show you a comma b is equal to, if you have an array 1 comma 2, for example, now we can just print a comma b and you will get 1 and 2. The similar thing is going on, but not with 1 or 2, some other objects or any information. Now if you have got the client socket, then we have to start capturing the video using the cv2.video capture. Once we start capturing the video, we have to check whether its video is actually running, it's open. We are using the while condition again, while video is opened. Now we are starting to read the information provided. We are reading the information using the video, that is cv2.video capture. Now the information is passed to us in the form of objects. Now we are storing this object in the frame. Image img is actually just a dummy in order for proper destructuring. And next we are storing a particular information in a. What's that information? It's actually pickle.dumps. It's this module, as explained later previously, it's used to convert the object. Now I said that we are getting object using this through this vid.read. That particular object we are trying to convert it into byte string. Now pickle.dumps does that thing. Now while sending the message, what we are trying to do is, for the first 8 bytes we are trying to send the length of the message, and the next 2 particular bytes would be an actual message. So we are using this doing this through this line. Now struct.pack q, which basically means 8 program according to the package itself, module itself. Struct.pack q length a. Now what is it actually doing? I will show it here in the test.py again. Let me import struct. Let's say a is equal to any integer, for example integer or any length. It should be integer, to be honest, if I'm using something like testing. Okay, now it's actually length of testing. Let me run this. Right, 7. Length of testing is 7. Now we are trying to convert this string into byte format using the struct. For example, b is equal to struct.pack q, just saying that it's 8. Is there anything else? Right, that's it. Now if I see this print b, yep, that's the byte format. It's actually hexadecimal byte format, it's actually byte string. I think you have understood. Let's go back. Now we are appending this particular length of the message with the actual message, that's actually a, the information that have been received through video.read. Okay, now we are sending this message using the client socket.sendAll. This particular message is actually sent. This will all happen only if there's an acceptance. Now we have to show the frame, that is the frame which we have read through the cv2, in order to show the transmitting video that we have previously seen. cv2.im show transmitting video frame. We are sending the frame as an argument. First is as a title for that particular window, and frame is actually the data that have to be displayed in that window. And we are using this particular 3 lines so that we can configure that window particularly such that if I press Q, the server will shut down. That's actually how we are going to send the video or the information through the server. Now coming at the client.py, similar 4 modules will be requiring. Similarly, we are going to configure our socket using the same command. Now we are manually setting this host IP address that we have received through server, that I have already shown you, and the port is similar 9999. Now we are going to connect. Now as soon as the Python code runs over here and it identifies that we are trying to connect, this particular code will actually accept. Next, data, we are initializing data with the byte string which is actually empty right now, and the payload which is struct.calcsize q. As I have already said, q represents 8. For example, once again I will show you. Delete this. Okay, let I accept this particular import. Okay, a is equal to struct dot calc size q. If I print it, you will see that it's actually 8. If I run it, that's it, 8. Okay, coming back to client.py, payload size is actually 8. Now why we are doing this? Because the first 8 bytes that we have sent, it is actually the length of the message. That's why you are setting our payload in the client.py as 8, that is q. Coming back, now we are going to loop through this code again and again until and unless we are getting the data. While length of data is less than payload size, at initial condition length of data which is actually empty, so let's say length of data is 0 and the payload size which is 8, hence the condition is actually true and this code will execute. Now packet is equal to client circuit dot receive, it's actually 4 bytes, 4 kilobytes actually. We are receiving 4 kilobytes of data again and again until the server is actually sending the message or video. Now you can configure it to 3 byte or 5 byte, that's up to you. We are not going to set it large amount so that in order to not burden our RAM. If not packet, if there isn't any packet, then we'll just break through this loop and not go any further. And data, we are going, if there is a packet, then we are going to append that to the data which have been initialized. Now we are doing this less than payload because we want the first 8 bytes. Now why do we want first 8 bytes? Because we want the length of the message that we have been receiving. Now packed message size is the variable which you are going to make in order to store that message, payload size. Now in order to make you understand this well, I said that payload size is actually 8. So we are retrieving the first 8 bytes using this. Let's say data is actually string, then we are retrieving that particular starting 8 bytes using this command, using this string function or method. For example, let's say our message is somewhat in a byte string or just a string, example a message, or you can just assume data is equal to, we have a string, for example 1 2 3 4 5 6 7 8 9 10 anything. Now we are going to retrieve the first 8 bytes. Let's say we don't want first 8 bytes, we just want first particular 4 bytes. Payload is equal to let's say just 4. Okay, I'll just remove this last one. Now the first means first, let's assume that first byte 4 bytes is equal to, now data, using the same command, same line actually. Now if I print this, now we'll receive the first 4 bytes, 1 2 3 4. This is actually the first 8 byte for 4 byte. Now the remaining message would be after the next payload data, after the payload right. What comes after the payload, that is 4 in our case, will be displayed. Example remaining. If I run this, these are the next remaining bytes. Similar thing is going to happen here, but instead of just 8 or manual configuring, we are going to send length of the data in a hexadecimal format. I have shown you before, that hexadecimal starting 8 bytes will be stored in the packed message size. Now the remaining thing would be data. Obviously data is equal to data payload size. After that message size equal to struct dot unpack. So we have used struct dot pack in order to convert that integer into a hexadecimal format. Now we are going to retrieve that or convert it back to the integer. If you want to example, import struct is equal to for example 8 anything, import struct a is equal to 8. So we are going to use b is equal to struct dot pack q, which q comma length of a, or we can just use a itself because we are just saying it's actually the length. Okay, now if I print b, which I have already shown, now I am going to show you unpack. Let's say c is equal to struct dot unpack. Unpack the thing, it's 8 comma q means 8. Now what are we going to unpack, which is packed message b. Now we have to take 0 because it returns an array, and we need it actually returns the tuple, and we need the first element of the tuple. Now if I print this C, here comes our 8 back. Previously it was hexadecimal, and using the unpack we have retrieved the message that is 8 coming back. Okay, while length of data is less than message size. Now we know that message size is actually something that have been set in the server. Now until there is a message, that is while length of data is less than message, we continuously receive that particular message using this command again, and we are getting the frame data using the same of the string methods data colon message size, which actually shows takes the frame data, and next to data is actually the message size colon. Now we are using the frame data in our actually converting the data. Frame data is actually in the byte format, byte string. Now we are going to convert it back into the object, which actually it was actually previously the object, as I have said here in the video.read. It is actually object. We have used pickle.dump in order to convert into byte stream. Now we are converting it back into using the pickle.load, converting it back into the object. Now I am using that object again frame to show cv2.im show receiving video frame. Now I am again configuring it in order to break the code. I mean in order to end this program when I press Q on my keyboard. Now the client socket dot close if there is no message or anything. If this actually breaks, the next line will obviously will be this. The socket will again close. Let's see it again. Okay, client.py python py. Here we go, and again transmitting video is actually hidden. That's it. Thank you for listening.